AniPortraitGAN produces high-quality, controllable 3D avatars with precise facial expression, head movements, and shoulder positioning. Difference using large-scale data set from Google Earth and OpenStreetMap, it learns to produce life structurally accurate 3D cities. The ability of AI to interpret, generate, and edit visual data is reaching unprecedented levels, opening doors to new creative possibilities and industrial applications. And dear friends, this makes it a powerful tool for film production, animated content creation, style transfer, and object-based video edits. Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are stepping into the fascinating world of AI-driven image and video generation, where artificial intelligence is pushing the boundaries of creativity, automation, and realism. Dear friends, imagine a world where you can simply describe a scene in text and AI generates a stunning high-definition video. Picture AI creating entire 3D cities with intricate details, designing life like digital humans, and even editing videos while keeping motion fluid and natural. So these are not just futuristic dreams, they are real breakthroughs happening right now. Yes, dear friends, in this episode we will explore 6 groundbreaking research papers that advances text-to video generation, 3D modeling, material capture, and AI-driven video editing. Each of these innovations represents a significant step forward in how machines understand and create visual content. So let's dive into these AI marvels one by one. Okay, the first one, it is on VideoGen, a reference-guided latent diffusion approach for high-definition text-to-video generation. Different text-to-video generation has long been a challenge in AI, mainly due to issues with frame consistency, high-definition output, and temporal coherence. This VideoGen solves this by leveraging a reference image generated using a stable diffusion model, which acts as a guiding frame for the video. The process begins with AI generating a high-quality image from the text prompt. Then, a cascaded latent diffusion model extends this into a full video while ensuring high fidelity and seamless transition. Finally, a flow-based unsampling technique refines the motion and enhances clarity. This approach significantly improves video quality and motion consistency, setting a new benchmark in AI-generated video. Difference, what makes VideoGen stand out is its ability to learn video dynamic more efficiently by conditioning the diffusion model on both the text and the reference image, reducing errors and making longer video sequence more stable. Applications range from automated content creation for marketing and entertainment to AI-assisted storytelling and simulation training. Okay, next it is CityDreamer, compositional generative model of unbounded 3D cities. Dear friends, this is very amazing paper. So while AI has made strides in generating natural landscapes, urban environments remain a bigger challenge due to their complex structure and human sensitivity to architectural distortions. This paper, CityDreamer, addresses this by separating buildings, roads, parks, and water bodies into distinct generative modules. Difference using large-scale data set from Google Earth and OpenStreetMap, it learns to produce life structurally accurate 3D cities. Unlike traditional procedure generation, which often lacks realism, CityDreamer captures authentic urban layouts while ensuring diverse building styles. Additionally, CityDreamer incorporates adaptive density modeling, ensuring that dense urban areas and suburban layouts are generated with appropriate scaling and variety. Amazing, no? So yes, this advancement is a game changer for urban planning, game development, virtual simulation, and smart city modeling, allowing AI to automatically construct expensive digital cities with incredible detail. Okay, next paper, it is Point-Bind and Point-LLM, aligning point cloud with multi-modality for 3D understanding, generation, and instruction following. Difference: understanding 3D data is one of the most complex challenges in AI. But Point-Bind and Point-LLM bridge this gap by aligning 3D point cloud with multimodal inputs like images, text, audio, and video. Point-Bind enables AI to convert any form of input as like text, images, or sound into 3D representation, unlocking exciting possibilities for any 3D generation. Building on this point, LLM brings language-driven reasoning to 3D by fine-tuning large language models like Llama to understand and process 3D environments. A key innovation is that Point-LLM enables interactive 3D scene reasoning, allowing user to ask questions about 3D spaces and receive context-aware answers. And dear friends, this advancement paved the way for AI-driven robotics, 3D content generation, AR/VR applications, and open-world understanding, making AI more spatially aware than ever before. Next paper, it is AniPortraitGAN, Animatable 3D portrait generation from 2D image collection. Difference: creating realistic animatable 3D portraits has been a long-standing challenge. But this paper, AniPortraitGAN, offers a breakthrough solution. Unlike past models that focused solely on either static heads or full body generation with limited expression control, AniPortraitGAN produces high-quality, controllable 3D avatars with precise facial expression, head movements, and shoulder positioning. What makes it unique is that its ability to train on unstructured 2D image collection without relying on 3D or video data. And dear friends, additionally, this AniPortraitGAN introduced a post-adaptive rendering pipeline, allowing smoother transition between expression and movements while maintaining high detail. This technology is a massive leap for visual influencer, AI-driven digital humans, video avatars, and metaverse applications, enabling highly interactive and personalized AI-generated characters. Okay, next paper, it is on ControlMat, a controlled generative approach to material capture. Difference: the process of creating realistic digital materials such as wood or metal or fabric has always required manual effort or complex lightning setups. This paper, ControlMat, transforms this by using AI-powered diffusion model to reconstruct high-resolution tileable textures from just a single photograph. Unlike traditional material scanning methods which rely on controlled lighting condition, this ControlMat intelligently analyzes and generates physically accurate digital materials, even when the input image has unpredictable illuminations. Another breakthrough feature of ControlMat is its multi-scale texture fusion. Difference which ensures materials look detailed at any zoom level, so making it ideal for CGI artists, game developers, and AR/VR designers who require textures that remain sharp under close examination. This advancement allows users to quickly and efficiently create hyper-realistic texture with minimal effort. Okay, next it is on MagicProp. Diffusion-based video editing via motion-aware appearance propagation. Different traditional video editing often struggles to maintain natural motion and seamless transition after making changes to individual frames. This exact paper, MagicProp, introduced a diffusion-based video editing approach that preserves motion continuity while allowing flexible content modification. The process starts with editing a single frame using advanced image manipulation technique. Then a conditional generative model that propagates these changes across all frames without disrupting motion flow, and additional enhancement in MagicProp's region-based edit tracking, which allows precision modification to specific objects without affecting unrelated areas of the video. And therefore, this makes it a powerful tool for film production, animated content creation, style transfer, and object-based video edits, enabling AI-assisted frame-accurate video modification with unprecedented ease. And yes, dear friends, from text to video synthesis and AI-generated 3D cities to lifelike digital avatars, realistic material generation, and AI-powered video editing, these breakthroughs are revolutionizing how content is created, modified, and experienced. The ability of AI to interpret, generate, and edit visual data is reaching unprecedented levels, opening doors to new creative possibilities and industrial applications. Which of these innovations excites you the most? Let me know in the comments. And dear friends, if you enjoyed this deep dive into AI latest advancement, don't forget to like, subscribe, and share to stay updated on cutting edge research. Keep exploring, keep innovating, and I will see you in the next episode. Happy learning, dear friends.